So let's start for today and we'll take grid paths. Okay, so would you like to go ahead with this? एक बार पढ़ के देखो कैसे इसको डिजाइन करेंगे वो सोचो in DP manner, right? In tabulation method, how would we go ahead with this question, grid paths? Okay, I'm giving you the link. Please, okay, sorry. Please start up with this. Think, how would we go ahead? What will be, think on 2 lines. What will be the optimal substructure? Correct. And how should we go ahead? How should we design that optimal substructure? Okay. Take 5 minutes to think, then I will proceed ahead. Correct.
Fine.
बन गया.
Yes, tell me.
So what we can do is we can start from the very end, like where we have to reach. We can start from that end, and we can simply iterate towards the starting node, right?
Okay.
And then we can check if we have a path, we can update the path. Like we can check if it's right and down. If there is, it is going to like goal node, we can add one to it, and then we can move backwards, and then check in its like successor nodes.
Okay, fine. So let's see how we can solve this question. Fine. I am taking a simple grid as of now. Let's say it is like this. Okay. Tell me if I want to reach this cell. Okay, I have to start from here only. The topmost left corner, right? From here I have to start off. So if I want to reach this cell, how many paths from this starting cell? Okay. From here to here, how many paths are there? Can you tell me?
One.
One.
One, right? Only one way. I can go to the right. Next, if I want to reach this cell, how many paths are there?
One.
Okay, so I can go just one step down, correct? And if I want to now reach this cell, how many paths will be there?
2.
One is by connecting this path and one by connecting this path, isn't it? Okay, just connect the path from the above cell and connect the path from the left cell, right? By utilizing these two cells, I can reach my destination D. So we have two paths here, right? Fine, let's take some other examples. Let us make now a 3x3 grid. Okay, from here, source, I need to reach the destination. Okay, now let's say I want to reach this particular cell. This is my, firstly, I want to calculate how can I reach this particular cell. Tell me, how would you design this? From source, I can reach this particular cell in just one path. I can reach this particular cell in just one path, right? These two cells have answers 1 to them, respectively, if I am not wrong, is it? Am I correct? Any other path is not possible. Next, I can reach this particular cell utilizing just one path and this particular cell utilizing just one path. Am I right? Am I right?
Yes, yes.
Okay, what about this particular cell? Can you tell me? If I want to reach here, how many paths are possible?
2.
Okay, one is from this, one is from this. Okay, so how many paths are possible for this particular cell? 2. Now next, okay, I think, yeah, let us keep our answers here. Okay, let us keep our answers here. And let's see, this is my starting. This was 1, 1. This was also 1. This was also 1. This was 2. Fine. Now next, this particular cell I want to reach. How many paths will be possible? Tell me.
3.
How 3?
1 from the top and 2 from the left.
So 1 from the top, 2 from the left. Getting it? All of you?
Yeah,
1
yeah.
from the top and 2 from the left. Yeah. So this can be reached in 3 ways. Okay. Now next, this particular path, this particular cell rather. How many paths we require, or how many paths do we have to reach this cell? Tell me.
Three.
Again 3, if I'm not wrong. Is
2
it?
from the top
Yeah.
and 1 from
2
the left.
from up, 3 and 1 from left. Next, this particular
Six.
cell, the last cell. 6,
6.
right?
Yeah.
3 from above, 3 from down. So what can I say? What can I say? If you want to design the optimal substructure, how it would look like for any particular cell XY? The total number of paths I can reach, okay? The total number of paths I can make from the source to this cell is dependent on what? Is dependent on what? Is dependent on two particular cells, I guess. One is what?
Right and down.
How many paths I do have from source to reach to x minus 1y, and how many paths do I have from source to what? X, y minus 1. If I have these two data, I can just combine them or add them to form the answer of xy. Getting it? So how would you design the optimal substructure, or how would you design the answer for any particular cell xy? dp of xy will be equal to what? dp of
X
what?
of y minus 1
X of y minus 1 and
plus
plus
dp of x minus
dp of
1 y.
x minus 1 y. Yeah. And some base cases are to be handled. What are they? Always for the first row and first column. Okay. All the cells of the first row and the first column can be reached in just one path, if I am not wrong. Is it?
Yes.
Getting it? All of you? Is it correct? Have you got the logic?
Yes,
And-
yes.
And if there is a like obstacle, then it is
Yeah.
0.
Yeah, for any obstacle that we have, it can never be reached, right? It is a blocker for us. So for any of the cell that I have, I can never reach this cell. Okay, so the number of paths to reach this cell will always be 0 for any obstacle that we have. Correct? This is an addition to the question that we have. Okay, can you code it down? Tell me.
Yes.
All of you?
Yes, yes, yes.
Okay, 2 can rest. Arif and Wasim.
Yes, yes.
Yes, yes.
Okay. Go ahead and try to code this. Go ahead.
बोलेगा यार उनको पाँच मिनट
Okay, anyone is done? Have you done this? Anyone is done?
Yeah, done.
Okay, one is done. Rest.
I have also done. I am checking with the inputs.
Okay, so let's solve this question. I think this is pretty easy. Fine. What we require actually here, tell me. What we require? We require to take. Okay, now don't miss that you have to print the answer with the modulo, right? And what we require here, tell me. First, we have to take the n, value of n that's given here, and then we have to take input for the entire grid, I guess. So it is n, let's take the input. Okay, I require to take an entire grid, right? So I am making a char. Okay, not required. We can utilize vectors, I guess. Yeah. Vector char, that will be a 2D vector, right? So I will say grid, and it will be having n rows and what
In
it will
column.
be
In column.
vector. It will be also vector char of column n, right?
In.
That's all. Yeah, fine. Now let's take the input for the grid for anti I equal to 0, I less than n, I plus plus. What we are to say, C in, and okay, yeah, sorry, there will be another loop, anti j equal to 0, j less than n, j plus plus. C in, I will say grid of
In
ij, right?
process. Yeah.
Okay, fine. Now, similar to this, we require something else as well. What is that? Tell me. So that will be what? Let me say long. For better accommodating my large answers, I will utilize long. And this will be what? This won't be grid, but this will be my DP array. Fine. Now tell me, how should I design my answers? I require one more thing. What is that? I require the mod value. So 1, how do you initialize that? Tell me. 10 to the power 9 plus 7. How do you initialize that?
1 in 9, 7.
1 in 9 plus 7,
Plus
right?
7.
That's all. So this exponent means 10 to the power 9. Exponent here implies that how many zeros are there after 1, okay, in the power of 10. So that's all. And let's move on. So what I can say, how many paths are there? What do you think? How many paths are there in the first row and first column? Tell me that.
1.
So okay, so there is only one path, right? So firstly, let us initialize our answers for
First row and first column.
the first row. So what I will say, DP of first row and first column. What is it? Okay, one thing I need to check, right? One thing I need to check. Fine. This is a trap for us. This is a trap, I guess, isn't it? This is a
Yeah.
trap for us. So
Obstacle.
if suppose the first cell itself is a trap, then what I should say? I should just
Return
check
0.
if grid of
0,
zeros is a trap, or there can be one more trap as well, right? What is that? Grid of
ending. N minus 1.
and n minus 1. If these two are traps for us, then what I should say, what I should print?
Cout 0.
There are 0 paths then, yeah. Fine. Next, what should I do? If this is not so, I will go ahead to calculate my answer. So what I can say, if this is it, I can return 0 from here as well. There is no need to go further, correct? Now next, what I should require, if this is not the case, we may try to check for answers. How that will be? So I will say DP of 0. I am initializing my answers for the first row, 0 and I, column I. In the 0th row, column I will say there exists only one answers, but when should I say so? Can you tell me? I should initialize the answer when to 1. If DP of I, right, DP of 0, I is not an obstacle for us, right? Is not an obstacle. Then only I will say initialize the answer to 1, correct?
Yeah.
Next, what I should say for columns, tell me. What should I say for columns? Similarly, what I should say for for columns, that okay?
I
For
0.
the ith row and 0th column of the cell, sorry, ith row and 0th column, this particular cell, if this is not an obstacle, please initialize the answer to 1. That okay?
1.
Exactly one answer exists here. Okay, so have we done it fully correct? What do you think? Have we done it fully correct? I don't think so. Something is wrong. In whatever we have done here, something is wrong.
Yes, the wrong part is we are like we are marking 1 even after the like obstacle is we have recognized as obstacle, we are marking it 1.
Okay, so what
I am saying that if
yeah,
if I have
getting it.
obstacle at star, we are marking further 1, it's 1.
Yeah, so what is happening is, in our case, let's suppose this is my grid. This is my starting cell, and let's suppose this is a obstacle for us. If this is an obstacle, I cannot go to these cells as well, if I am not wrong, is it? Similarly, if the next column, if the next row, first column, okay, next row, first column, if this is also an obstacle for us, we cannot go to further cells, I guess, this and this. So somehow we are missing this, correct? So how should we design our question? What do you think?
If
So
we found
let's
the
first,
obstacle, we will break there.
okay, no, we won't break. Let's see how to easily do this. So
We
I
can
will say,
iterate from last one, that would be easy for us.
okay, we have already checked for this.
Yeah.
We have already checked for this, right? Then what I can say, dp of 0, 0. If this is entire of this is not the case, right? Then what I should say, dp of 0, 0. dp of 0, 0 will be 1, right? Now let's move on for all the cells that we have. For int I equal to 0, I less than n, I plus plus, and what I will say, int, yeah, whatever happened, int j equal to 0, j less than n, j plus plus. What will happen here? Tell me. Now let's handle the situations here. What I will say, if suppose I am on the first row, right? If I am on the first row, or let's say for more betterness, let's say that if grid of ij, if this is equal to, if this is not equal to, what I should say, rather, let's say if this is an empty cell for us, correct? If this is an empty cell for us, then only I will try framing the answer for it, correct?
Yeah.
Okay, so what should I say? Tell me, what should I say?
dp of ij is equal to.
So what should I say if, how would you frame? What do you think? So let's do one thing. Let's do one thing, that let us say, okay, for the characters we don't, but the initial answers for each and every of our cell, let it be 0. Fine. By default, we have said every cell of my DP array will be, DP2D array will be 0. Okay, how should I go ahead now? Tell me. If suppose I am on the first row, right? I am on the first row. Then what should I say? If I am on the first row, then what should I say?
And dp of ij is equal to 1.
So what I will say, if j minus 1 is greater than equal to 0, then do what? Simply dp of ij will be equal to what? dp of ij will be equal to dp of I j minus 1. Getting it? Simple, nothing to do here. Okay, fine. Else if my, let's say I am on the first column, j is 0, then what I should say? If the above row, whatever I have, if I can go to one step up, then simply I would, okay, what has happened? Yeah, if I can go one step up, I can go a row up, then what I will say, dp of ij will be equal to dp of I minus 1j. Simple, nothing else. Next, what should we do? We are done with this, right? Else we are not on the first row, not on the first column. Then what I can say? Simple is that dp of ij will be equal to what? dp of I
dp of
minus
I minus 1 j
j and
plus
plus
dp of j
dp
minus
of
I j minus 1.
j minus 1. Simple, right? Okay, this will not work only in this case because we have to take mod. How would you
Yeah.
do that?
We will take
We'll
both the
say
mod and
mod
the
of
entire
this.
mod, then
Yeah, mod of this, and then
entire mod.
entire mod. Yeah. Fine. Anything else we should do? What do you think? Else it will be remaining 0. If it is not a dot, I will not frame any answer for that. That will be by default 0, whatever I have assigned, right? And at the end, what I need to print? At the end, what I need to print?
N comma n, n
dp
minus
of
1.
n minus 1, n minus.
Yeah.
That's all. We are done with our answers, I guess. Okay, let us take the input and then let's see whether we are getting the correct answers or not. Fine. Here it is. Let me try running this. What has happened? Yeah, there is no. Okay, what is the mistake here? Can you tell me? What I have made a mistake here? This will not be a vector, but a vector of vectors, if I am not wrong, is it?
Yeah, vector,
A
vector.
2D
2D
vector
vector,
rather. That is the mistake here. Yeah, fine. Correct. Let me try running this. Okay, answer is coming good for this. Let me try submitting this, right? Okay, main 3. Let me try submitting this. Submit. What is it, by the way? Downloads. Fine, main 3. Let me open this. You try submitting. Okay, everything is accepted. There is no problem. Correct? All of you understood how we coded this up?
Yeah.
Any doubts? Anyone?
Yep.
So what is the time
No.
complexity expected? What is the time complexity of this entire approach? Please tell me.
N square, I think.
No.
Yeah, n square. For each and every of the cell, okay, what is the total number of paths? Okay, I can reach to this particular cell from the source. Correct? So for each and every of the cell of my DP array, I will frame the answer. So I am going to exactly big O of n square operations. What is the space complexity? What do you think? What is the space complexity? I am utilizing an extra DP array, extra.
Yeah. N
And
square.
that is also
N square.
have big O of n square extra spaces, right? Big O of n square extra spaces I'm utilizing to solve this question. That's all. Fine. Okay. Let's
Is there any
move
way
on to
to
what other
optimize it
question do you
further?
want? There is no other way to optimize
Okay.
this, I guess.
Okay.
Fine. Okay. This is the most optimized version. Earlier, we have solved this in big O of 2 to the power
N
n
into n.
square time. Yeah. 2 to the power n time, I guess. Yeah. Maybe. Okay, I have forgotten that. I need to derive it. Okay, fine. What else would be taking up today? Tell me. Let's start up with this coin combination 1. Fine. Okay, try this. Think for 5 minutes. Try this. How would we solve this? Fine, coin combination 1. Then I will show you. Giving all of you the link. Please try this.
इसमें कोई मैथ्स लगेगा
Okay.
क्या?
अच्छा ट्राई करो, जस्ट सिंपली फ्रेम करने को ट्राई करो, देखो होता है या नहीं. ठीक है ना? मुझे नहीं लगता कि ज्यादा मैथ्स की जरूरत है इसमें.
अच्छा,
Okay, any ideas? Anyone has? How would we solve this?
We
I
can
think
maintain a DP array which would represent amount and like sum which we have to generate, and then we can start from one to desired sum.
Okay, so
And
this is
then
my 2, 3, and 5, right? The number of coins. So what we need, if if I am to form the sum 9 using these coins, right? What states I need to visit? What do you think? Okay, the
yeah.
number of ways, right? The number of ways I can make 7 utilizing these coins. Okay, the number of ways I can make 6 utilizing these coins. The number of ways I can make 5, sorry, not 5 but 4 utilizing these coins. How I can visit these states? What made me visit these states? What do you think? 9 minus 2. Okay. I will in whatever ways I can make this 7, to them I will just add 2 and will form this 9. To whatever ways, how many ways, whatever are there, I can make this 6. To that I will add 3 and I will make this 9. To how many ways? Okay, whatever are the number of ways I can make this 4, to that I can add 5 and I can form 9. Fine. Let this be X, let this be Y, let this be Z. So my total number of ways, okay, to form 9 will be X plus Y plus Z. Getting it? Okay. How many ways I can make 7? Let's try to form the answer for this. How many ways I can make 7? Can you tell me? One can be 2 plus 2 plus 3, right? Another can
3.
be 2 plus 5. Another can be 5 plus 2, right? Next, this can be, there can be some more permutations of this. What are they?
2
What
through
are
3.
Another can be 4 plus
2
3.
3 2.
2 plus 3 plus 2? Next,
3
next,
2.
3 plus 2 plus 2, right? These are the 3 ways, I guess. So in total, I can, is there any other way I can form 7? Tell me that. This is the way, I guess. Total 5 number of ways I can form 7 to all these paths. To all these paths, 3 plus 2 plus 2, add a 2. You can go to this 7. Now 2 plus 3 plus 2, add a 2 at the end. You can go to this 7. 2 plus 2 plus 3, add a 2 at the end. You can visit this 7. Now next, okay, no, sorry. To all these ways, these are the, till this point, till these points, we have made 7 till these points. At the end, if we add 2, we can visit 9. Getting it? We can visit 9. Now again, 2 plus 5, 2 plus 5. If I just add 2 at the end, I can visit 9. If I am not wrong, is it? Next, 5 plus 2, 5 plus 2. If you add 2 here, you can visit 9. Anything else we have missed here? Okay, so these are the ways. From 7, there were 5 paths. Okay, and utilizing these 5 paths, I can go and visit 9 if I just add 2 to it. Okay, at the end of these 5 paths, if I just add 2, I can visit 9. So from 7, I have how many paths? 5 paths to visit 9. Correct? So to the X, I will substitute 5. There will be Y number of ways I can form 6. There will be Z number of ways I can form 4. If I combine all of them, I can form the number of ways I can form 9 utilizing these coins will be the answer here. 5 plus Y plus Z. Okay, X plus Y plus Z in a sense. Getting the point? How would we solve this? Is it clear?
Yeah.
Hello, am I audible?
Yeah, audible.
Yes.
Hello.
Hello, hello.
Hello.
Yeah,
Hello?
Hello.
audible.
Yeah. Tell me, is it clear?
Yes.
Okay. Now, okay, let's try to form the answer for this from 1 to 9, I guess, right? We have seen how many states from where to where, from 9 on an upper level. How can we go there? So I will form an array from 1 till 9, I guess. 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Now, next, what we should do? What is the number of coins we have? 2, 3, and 5, I guess, right? Next, what should happen? For 2, we already have a
1 coin.
one way, right?
Yeah.
One way that I can just utilize this particular coin to form this 2. Now
2.
3, I
1 way.
already have one way. For 5, I already have one way. 1, can you form it? No. So it is always 0. Now I have to start forming. From where should I start forming? What do you
2.
think? Okay, now I have to start forming from 2 onwards. It's already 1, right?
1.
And there is no other way I can form this 2. 3, is there any other way I can form this 3? No, only 1, 3 is sufficient. As of now, there is no other way utilizing these coins and I can form 3. What about 4? What about 4? What about 4? How can we form this 4? What do you think?
Two
0.
twos,
Okay, so what I can say,
two twos.
from this 2, From this 2, I can add. In how many ways I can form this 2? By just one way. So add it here. For forming 4, utilizing now the number of ways I can form this 2, to that I will just add 2 to form 4. So I have one way. I have one way. Next, for 5, is there any other way I can form 5? Can you tell me?
Yes, one more way, 3, 2.
Yeah. What is that?
3, 2.
So, okay,
3, 2.
what is that? I can start forming. I can just go to 3 by subtracting 2. By subtracting 2 from 5. I can say how many ways I can form 3. There is already one way. So plus 1 to this. Next. Can I go to any other path from here? Tell me.
So,
Yes, I can, right? I can subtract
2, 3.
from 5. I can subtract 3 and I can go to this 2. I can go to this 2. So I can say that, okay, in how many ways I can form this 2? In one way. So add 1 to it. So in 3 ways I can form 5, correct? Now 6, come to this point 6. How many ways you can form 6? What do you think?
3, 3. 2, 2, 2.
Yes.
2.
Yeah.
How many ways you can form this?
2 ways.
Firstly, minus 2. Minus 2. Go to minus 2. 6 minus 2. First visit this state. 6 minus 2. So we can visit 4, right? In how many ways have we found 4? Only 1.
1.
So plus 1 to this. Next. 6 minus
3.
6
6
minus 3.
3.
In how many ways I have formed 3? 1.
1.
Is it? Plus 1
Yeah.
to this. Okay, next. Next.
7,
Not
0 ways.
possible.
6 minus what? 5. Is it?
I will lead to the 0.
6 minus 5 is 1, right? And 1 can be formed in 0 ways. So I can form 6 in 2 ways. Should that be the answer for us? One is what? 3 plus 3. Another is 2 plus 2 plus 2, right? This is
Yeah.
how we have formed 6. Okay, fine. Next, let's find for 7. What is that? Can you tell me?
0. Yeah, 5 and 2.
Okay, so 7 minus 2, we can go and try visiting 5. How many ways we have found 5? 3. So plus 3 to this. To all the 3 ways, I can form 5. Okay, to all the 3 ways, let there be X, Y, and Z. These 3 ways, I have found 5. To them, just add 2 at the end, and we will be able to form 7 from here, right? Next, from 7, where I can go? I have already visited 5. Now where can I go next? 7 minus 3, that is 4. One path from here, added 1. Next, 7 minus 5, that is 2. So one path here as well. One path here as well. So in 5 ways I can form 7. That's what we have also seen in the previous example, right? These are the 5 ways I can form 7. Correct? Next, 8. 8 minus 2, 6.
2.
Okay, 2 ways here. Next, 8 minus 3, 5. 3 ways here. Now, 8 minus 5, 3. One way here. How many ways have we formed 8? 2 plus 3 plus 1, 6 ways. Now 9. For 9, what will be the number of ways? Tell me. For 9. 9 minus
3,
2,
3.
7. 7 has 5 ways, I guess. 7 has 5 ways.
5
Now
ways.
next, 9 minus 3,
Minus
6.
6. 2 ways.
Plus 2 ways. Okay, now 9 minus 5, 4 ways, 1. So it is coming how much? 8 ways, if I am not wrong, is it?
Yeah.
Is it the answer? Or something we are missing? Okay, yeah, there are 8 ways. We are exactly correct in our analogy, I guess. Isn't it? Can you code it? Will you be able to code this? Quite similar
Like-
to the previous question that we have seen, I guess. This question, right? Minimizing coins. This is quite similar to that. Coin combinations one. Can you code this up?
Like I have coded, but I have coded the wrong code. Like it's failing. Like I don't know why.
Okay, so should we do that? Should we do that?
Which one?
This code, coin combinations one. Should we do that?
Like basically I have tried recursion code.
Okay, but I want you to go ahead with the tabulation form.
Yeah,
the
yeah.
tabulation method. Yeah.
Okay. Yeah. Yeah.
Would you be able to do that? Take 5 minutes, try to code. Take 5 minutes, try to code.
Okay.
Can you do that? Can you do that?
Yeah, we can do that. Already, like almost code will be of that money problem.
Yes, yes, yeah. How many of you can do? How many of you can't? Tell me that.
Yeah, can be done.
Okay, go ahead. Go ahead. आरिफ वसीम होगा या नहीं?
हो जाएगा भाई.
ठीक है. Try that. Try for 5 minutes. This is a pretty easy code, I guess.
Okay, okay.
Yeah. Is it done? Tell me. Is it done?
No.
Anyone?
Yeah, I have done it.
No, no, no.
Okay, make an account here, right? Make an account here in CSES and practice them and try submitting them. That will be better, I guess. So let's see how can we solve this. What we require is a vector of size n and what? The mod value will be remaining same. We require the sum value, whatever we want to form. So one is n, another is sum, I guess. And let me just see. Yeah. Correct. So I have taken for n, I have taken for sum. Now we don't require a grid, I guess. We don't require a grid, we require something else. Right. What we require vector. Again, let's take it to be long. what it that they will be coins, I guess, right? Coins of size n. Fine. Let's take the input for them first. For I equal to 0, I less than n, I plus plus. We'll take C in for coins of I. Okay, taken. Now next, what should we do? Okay, what we require now? We require a DP
Some
array,
vector
right?
DP array of some size.
Yeah, of size sum plus one, better,
Sum
right?
plus one, yeah.
Sum plus one, yeah.
With
We
0
require a
initially.
DP array. Sum plus one with all the values. Initially, let's say they are 0, correct? Now, what I am gonna say? What I'm gonna say?
We will
What I'm
iterate
gonna
over the
say?
sum.
How to code this? If coins of I are lesser than or equal to sum, right? Then what I'm gonna say? DP of coins of I will be equal to 1. At least in one way I can form this particular sum, right? So I have initialized its value to the DP array. Now next, what I should say? How should I go ahead? So let's try forming for 1. I equal to 1, I less than, let's see the constraints a bit. Yeah, that's fine. So we can, since 1 can be formed in just one way, right? That is, if we have a coin of 1, coin of value 1, then it can form 1, else we can't form it. That's the thing. So let's start off with 2, and we can go ahead with what?
Equal to sum.
I less than equal to sum and I
I
plus
plus
plus.
plus.
What we need to say here, tell me. What we need to say. So, okay, let's now visit all the coins. Point j equal to 0,
J is less than equal to n minus 1.
j less than equal to n, yeah, j less than n, j plus plus. What I should say now, tell me. How should I proceed ahead? If
Coin of I is less than equal to j.
yeah, or rather I minus coins of j, right? If
Yeah.
this is greater than equal to 1, I guess. Okay. If this is greater than equal to, or you can say this is greater than
Equal
0.
to 0.
Or else we can just say this is greater
Equal
than
to
equal
is
to 0.
okay. Yeah.
It's also fine. Yeah, we have already handled that. That 0 can be formed in just one way, that is 0 in 0 way, right? We can do nothing. So 0 can never be formed using any positive coin. That's what. So that has been already initialized inside the DP array. Now next, what we should do? I minus coins of j. If this is greater than equal to 0, then what I should say?
DP of I is equal to
DP of I will be equal to DP of I minus coins of j, right? Okay.
mod.
Right, this will be equal to what? Let me add it first. Now next, what I will do? DP of I mod equal to mod. Yeah, that's all. First add the value, then take the mod. It's fine, correct? Anything else we are leaving? I think we are done. And at the end, I need to do what? I need to print DP of n.
Sum.
DP of sum, yeah. I think we are pretty much done here, if I'm not wrong, is it? Let me try taking the example and let me try running this. Is the answer 8? Yeah, that's coming good. Let me try downloading this and then I will submit that. Main 4, correct. Submit. Choose files, main 4. Okay, let's see. Oh, for some of them we are getting time limit exceeded. What has happened? What do you think? One, two, three, four, five, 6. Yeah, so I think for some critical test cases, we are exceeding the limit. What do you think? What should we do here? Let me try doing this by some faster input output. Let me just try that, whether it works here for C++ or not. It should work. There are 3 cases where we have exceeded the time, I guess. Isn't it?
You can mod the answer before we print out.
Okay, this is one and next. Next, this is one. Yeah, we didn't print it. These are the extreme limits where we have. So I will
Yeah,
show
we
you
can
one
mod.
thing. Okay, I will show you one thing. It's our, it's coming within the time complexity. It might be that some operations are going extra. So what we can do, search for faster input output in C++. Fine. How this is a kind of thing that you can employ sometimes, right? To take faster input output. Just copy this code and paste it here. So sometimes you need to make your input and output faster. So for that, you can paste this line as well as you can say cout.null. Let me try with this first, whether this is getting accepted or not. What I'm gonna do, I'm gonna just make the input and output operation faster for C++.
We can mod the answer when we are, printing out.
Okay, fine. We'll try that. No doubt. Let me just try this as well.
Okay, okay. No problem.
Okay. Remain 5. Submit.
Pass. Pass. Oh,
Okay. Again 3. What is going wrong? That's even my question here. Even the faster input output is not working for us. There was nothing wrong I did, I guess.
can we mod the line number 36?
I can just say, right, from dp of this is equal to dp of I. This is gonna make no difference, I guess. Mod
And whole mod.
whole mod here. Yeah, let me try this.
You can plus sign, remove the plus sign, I think one line.
Yeah, I will do that. I will do that. Okay, let me try this. Let us try submitting this again. Main open C++. Let me have C++. Okay. Will
No,
that make
14.
any difference? Let's go ahead with C++ 17. Let's see. Okay, again time. Now two cases.
I have put one code in the comment section. Working fine.
Okay, now two things are going out for us. Earlier that this one was getting printed, I guess. Okay, let us try to submit this in C++ 11 again. I don't know why things are going wrong. Okay. Okay, yeah. So the previous approach was a little bit better. Even this is a hefty one that we are doing. Right. Yeah, yeah.
Yeah. One thing.
I tried making this.
Can we mod the line number 36 too?
It doesn't matter, I guess. That will already
We can
been
try it once now.
that will already been calculated. Can try this.
Yeah.
So yeah, one operation is going good. That is here. Initially we were just adding this. We were just saying dp of I minus coins of j, and post that we were doing what, dp of I mod equal to mod, right? We're just adding this and doing this. Anything else we should do? What do you think? Mod is not, will not make any difference here because mod is just an operation. Okay, sorry. What should we do else?
I think it should pass now.
Ah, okay, so let's do one thing. I won't go that much now. I won't be utilizing vectors. Let's do one thing. Let's utilize coins of size, a global coins of size 10 to the power 5, and the sum will also lie within the range, I think 10 to the power 6, right? Here I have also 1, 2, 3, 4, 5, 6. Yeah, and let me just see that it is also of the range 10 to the power 6, the sum, I guess. Yeah, sum and coins, everything. So the coins I have taken, now I will also say long what is that?
Sum.
Sum, not sum. Will it be sum? That would be DP, I guess, right?
DP Saji.
Egg 1, 2, 3, 4, 5, 6, right? And yeah, so one thing we need to do, till n, right? We have to just say, okay, let me try doing, let me remove this first, and let us keep the DP till some +1 and 0, right? Let me try with this first, that again and again the declaration of such huge array will be omitted. I don't think that's making a difference here, but let's see. Fine, let me try once to submit main 7. Yeah, let me try submitting here. Okay, time limit exceeded again for 3 cases. One is here, another is here, another is there. Yeah. The sum is huge. 1, 2, 3, 4, 5, 6, 10 to the power 6. It's just that we are having 100 size of coins. Okay, fine. Let me just see how can I optimize this. Then I will get back with the code. Fine.
I have put one code in the comment section. Can
Okay,
try.
let me see. Let me see. Yeah. Fine. Let me just try this. Okay, Arif has put one code here. Let me try this. Okay, and let me see. Okay, into the main file, if I open this, fine, that's gonna take some time. Let me do one thing. Let me open another IDE, C++14. And here I will paste it and I will download this. Isn't there any download option from Geeks for Geeks? Yeah, there is here. Code4.cpp. Yeah, quite a bit. Yeah, let me try this now. This one is getting accepted, but this 10 to the power, the above one is not getting accepted somehow. Let me try submit the code 4. Whatever Arif has given. Okay, it got accepted. But what you did here, special. Just you have
Everything is
keep
same,
it.
almost same.
Yeah, it's almost same. There is nothing difference, but there might be some faster operations that's happening. Instead of instead of long, they have kept int.
I define on the line number 4 now.
Yeah, okay, yeah. So that, yeah, these operations are a little bit faster. If you, rather than declaring a variable, if you utilize hashdef statements, right? Then though these statements work faster in C++.
Yeah.
Okay, so hashdef, you say int, then long, then fine. Then what you did? Yeah, fine. So yeah, hash defined statements are sometimes utilized for faster operations. This happens. rather than utilizing the original variable again and again. So while the compilation, what happens, wherever you have written mod, na, this 10 to the power 7 value is replaced there. Wherever I have written this hash defined statements. Yeah. So, okay, fine. So this is the way we can utilize further in our upcoming classes. Correct. The logic is same. There is no difference in the logic that we have utilized. It's just that some hash def statements are there here. So what is the time complexity? What do you think here? What is the time complexity of this question? Tell me. Hello.
Yeah, no idea.
No idea.
Like, what mean that?
Okay, so what is happening from 1 till sum? I am forming the answer, the number of ways I can form any particular sum x from 1 till the main sum, right?
Yeah.
I am forming the answer for each and every one of the cell inside my array. Okay, and for each and every of the cell, I am visiting every coin, if I'm not wrong, is it? From ith to, from 0th coin to the n-1th coin. Every coin I'm utilizing and trying to frame whether utilizing any coin y here, I can form the sum x or not, correct? So for each and every of the sum value from 1 till sum, I will form the answer utilizing n coins. So what is my time complexity? Big O of sum into n. Getting it? Getting it?
Yeah.
And extra space, what we have kept? This DP array. So big O of sum. This amount of extra space we have utilized. So this will be our space complexity.
Okay.
Okay, is it fine for everyone? Is it
Yeah.
good?
Yes.
Okay. Try to think of now for the next question. What is that? That is coin combination 2. Try to come up with any solution. Okay, there is a significant difference between coin combination 1 and 2. Okay, next day we are gonna see this question, coin combinations 2. Fine.
Okay.
This is a very good question. Can you just tell me that what is the difference between coin combinations 1 and 2? What are you getting? That these are the number of ways I can form in coin combinations 1, and this is the number of way I can form in coin combinations 2. This is the number of ways I can form any sum in coin combinations 2. So one difference I am saying you that, see, okay, there is, okay, once you trying to form 9, okay, you can form any coin continuous time. Once you leave this, you cannot revisit this coin, unlike what we have seen here. Unlike what we have seen. Okay, so this is what is happening inside this question. See, okay, I'm showing you 2 can be picked up at any point, right? The sum
Yeah.
2, okay, to form the sum, this 2 can be picked up at any point. It can be picked once, then you pick 5, then you pick 2, correct? But here there is a restriction in the next question. What is that? The restriction says me, once I drop 2, once I stop utilizing 2, I won't be visiting this coin again.
Okay.
Once I have stopped utilizing it, it is not coming back again at any point of time.
It's like a coin
Okay.
combination sum 2, I think. No duplicate element.
Yeah. So
Yeah.
please go ahead with this. This is just whether I can coin X. If any coin I try to pick up, whether I'm able to pick up or not. Okay. If I try to pick up this, I can pick up or I may not pick up that. These are
Okay.
the two choices I can keep here. All of you. Fine. Please try this. Next class, we will see this question, coin combinations 2 first. Okay, try करके आना tabulation method, right? कोई recursion बेशक करो, recursion से recurrence निकालो, फिर tabulation करो इसका. ठीक है? Then we'll go ahead with the rest of the question. Okay. All of you understood whatever we have discussed today? Please tell me.
Yes.
Yes.
Yes,
All
yes.
of you.
Yeah.
ठीक है, ये कॉइन कॉम्बिनेशन 2 बस ट्राई करके आना. ठीक है, इसमें 2 लगेगा, बता दिया मैंने पहले से. अब ये सोचो कि लगेगा तो लगेगा कैसे. ठीक है ना?
ठीक है.
ठीक है.